Firstly, the question of your friends is that how can we select the current or the any input values for a system? In a simple case, we can build the car example in here, okay? If you have a car like this one, and also if you have applied the f value, this is maybe 100 meters and 0 meters, and our objective is that we want to drive the x to the what, the 100 meters, right? We want it like this one, because at any case we closes the reference meter in here, but in real life application you can control this car, okay? But if you have this information in here, just like this one, the x, and this the f value, the force value, okay? Or this could be a pedal angle, right, in a car. And so assume that you apply this force to this car. How can be outcome of the x in here? 10 Newton, for example. This is the 10 kilogram, okay? And so what if I choose the f is equal to the what, the 10 Newton, or I always constantly push the pedal at any time, and so this is moves with the what in these terms, because at each case the acceleration is positive, right? We have the 1 meter divided by second acceleration value, x dot dot, right? But in normal case or your life, if you are closing to this value, and so you apply this kind of force, right? And so if you have this nomination in here at each case, and if you are closing this value, at some points the force must be 0, right? And if this is the case, this gives us to what? To this output, right? Just like this one. For example, if I move just like this one, and so I'm closing to here, and so I'm increasing my speed, and after that the Newton or the force value is 0, right? And so if I choose to run this one, but I cannot stop it right now, right? Because I want to go this way, but if I choose this one, and so I can stop in here, because my force must be what? Decreased at closing to these values, right? And so how can we obtain this force curve? This force curve can be obtained using the what? The control theory. This is the answer of your question, okay? We always condition the force value to be applied to the system based on the what? The control theory, okay? Or its theoretical calculations, right? Okay. Otherwise, if we are choosing this one to control this, and then this cannot be stopped at the 100 meters. But in the next weeks we will talk about it in the real systems, okay? But in this lesson we should give the what? The section 4 information, the analogy principle. Have you heard about the analogy principle? You know it? Okay. In universe, every part or everything must obey the some rules, which is based on the energy. Okay? Because if you have an energy, we can define it in two forms: the potential or the kinetic one. Kinetic is move, or directly related to the water dynamicity of this system, based on the water time variable, right? But the potential has the some energy to be consumed by the moving objects or the another else. Okay? And so at all time, if you want to move or give the some direction to any parts, we take the potential energy to the kinetic one. Okay? If we want to stop this system or any part or any objects, we want to give the energy to the potential one. And so at always these two converted into each other with based on the minimum principles. Okay? Which is called the least action rule, which is based on what nature always seeks the most efficient way to complete that task. Okay? And so if we have any ball putting with my head, and so if you drop this ball movement or the dynamics must obey the least action rule, because it creates the dynamicity based on the minimum principle. And so if we have the position or velocity value for a given system, and then the energy can be minimized to build or create its dynamic form or dynamic equation, just like the Newton law or Kirchhoff law. Okay? Every single equation which is given in your electrical circuit theory or the dynamics or the system dynamics or the heat theory is the minimized energy form. Okay? This creates the dynamic form of the equation based on the derivative and the integral operation of these terms. Okay? For example, the Fermat principle. For Hamilton classical mechanic. You know this Hamiltonian classical mechanics as the Newton mechanic or the Newton dynamic. Okay? Kinetic potential energy formation is proved by the Hamiltonian form. Okay? But this energy are the same for the mechanical system or the electrical system or the heat system or the fluid system. And then we can create an analogy between these terms like this one. For example, if you have any information about the electrical theory, like the resistor, capacitor, current, voltage value, we can convert everything or write everything into the mechanical one. Okay? And so if we have these systems, and we can define the electrical notation. Electrical notation or the mechanical notation or the hydraulic notation. Okay? And so we have two definitions in here, like this one. We have the across variable or the difference variable in here. For example, if you want to drive or create a current in an electric circuit, we need to give this system to the watt to the voltage, right? If we applied any voltage to the resistor or capacitor or the inductance, and then we can create the current or flowing variable or true variable by using this term. But in mechanical system, which one should be applied to the system to move the objects? Force, right? In hydraulic system, pressure, right? This is called the across variable at every definition of these input values. You must know that this is the delta F, delta pressure or delta voltage value, because we have the ground value, right? So if you have any movements in here like this one, I can take it off this phone, but my arm apply the force this value with respect to the what, the stationary objects, and so it can be called the delta F or changing values in the force value. Or in electrical circuitry, you always define a ground to what? To detect what is the main voltage or the voltage difference applied on the system. The mechanics cannot easily be analyzed by these terms, but in electronics you can easily see that, okay? But in the mechanics the same rule is applied, okay? And so also we have as storage elements or variables in here. What is stored in electrical system? Capacity, but as a charge, right? This is a charge, okay? And what is stored in mechanical systems? No. What is? No. Just like see that this is a charge value. We store the charge in the what? The capacitor. No, spring is an element to store the energy, but what's the formulation of the spring? F equals to what? The K times X. And so the mechanical system stores the what? The position, right? Because if we have a spring and then we have the what? Some displacement. And so after this displacement occurs, and then we will get the energy storage, right? And what if in the hydraulic systems, mass, we store the mass, right? This analog. And so also if we have an across variable and storage elements, just think that the potential energy is directly related to what the storage elements. The across variable is given or provided to this system by the outside, right? Because my phone is a system, but I can move it in the up and down direction. And my force is an external force, not an internal one. But in my arm, I can push or split my hand like this one. But where's the coming from this force value? In the muscles, right? This is the internal input, right? Okay. And so we have the true values or true elements or the variable in here. What's the true elements or the variable in electrical system? Current, because dq divided by dt, which is equal to the what? Current. What's the true element in mechanical system? Velocity, because dx dt must equal to the what? The v, velocity value. what is the true elements in here? The m dt m dot, which is the mass flow rate, right? And so if you have a system, we always apply the across variable to the what? To the storage elements, and the balance equation coming from the what? The true elements, right? This is the effector of the system. This is the what? The balancing current or true variable. This balance holds the system for a given across variable. Okay? If we apply the voltage and then some currents happens on the resistor or the capacitor or the inductance, to what? To provide the minimum principle. Okay? Because they don't have any choice but to through this current to provide the what? The minimum principle. Okay? This is the basic notion of the what? The analogy principles. And so, how can we utilize this formation in an example? Just see that if we have any spring and damper coefficients with the what? The m, how can we create the dynamic equation of this form? Firstly, we have the effector in here, like this one. F must be equal to the what? Because it's the total energy coming from the what? The external world, right? It's the external effect. And so we have a mass in here. Some energy should be consumed with the what? With this term. And another term is the what? Some energy should be consumed in the damper coefficients, and some energy should be stored in the what? In the spring, right? And so this is the what? The storage. This is the what? We cannot reverse this energy in here, and so the loss energy, right? And what is that? No, it's the potential which is in here. What is this? True elements, but what is this? Yes, the inertia and m or mass always preserves the energy. Preserve energy. Because if these two terms are removed in this equation, and then we can increase the velocity value to these objects at all time, right? And so this preserves to the what? To the total energy. Just think about it. If you have the bottle, and so you can put the water into this bottle, and at each case we store the what? The mass, right? Just like this one. Okay? This mass has a velocity based on the what? The momentum equation, and then this mass preserves the whole energy which is coming from the what? The external world. Okay? But how can we utilize the analogy, or how can we convert this equation or the free body diagram into the what? The electrical one? Firstly, we have a force value, and so what's the representation of the force in electrical domain? Volt, right? And so we have the what? The voltage value should be given to the any space. And so just like this, that this is the Q, right? This is the Q dot, and this is the Q dot dot, right? And so if you have this notation, F is C X dot, and so F is equal to the voltage, and so X dot is represented in the electrical domain with the what? Huh? Current, huh? Okay. Current. And so, what's the representation of this C in the electrical domain? Resistance values, okay? And so, we need to add the resistance, right? And so, at each case, we have a serial element. At each time, we apply the force to the watt at all time, this preserve energy, loss energy, and storage energy. And so, if we have this information, and then we can say that the F equal Kx, F voltage, and X is the what? The Q. And what's the value of this term? C, but 1 over C. 1 divided by C. Because the Q is equal to the what? Voltage time capacity, right? And so, if we have this information, and then we can say that we have the C in here, okay? And what about that? F is equal to what? The mx dot dot, and F is equal to what? The voltage, and x dot dot, q dot dot. Q dot is equal to what? The current. And so, this is equal to di dt, and what is this coefficients? This is the L, right? And this is the inductance value of these terms, okay? This is the identical analog of the what? The mechanical system in the what? The electrical domain. We can either utilize these terms or this one, okay? Just like the hydraulic system, we can create the what? The system dynamic equation based on the what? The electrical analog circuits, okay? For example, if we have, or so we can build this one. If we have the any hydraulic system like this one, we have the one resistance value or the valve value in here, R1 and R2, and so we have the some mass to be stored in here. How can I give the P in and this to 0? How can I draw the electrical analog circuit based on this information? Firstly, what's the value of the P in what? In electrical domain? P is voltage, right? Okay, and so we can give the what? The voltage value in here like this one, and so we have the what? The resistance value in here, R1, and also we have the R2, which is going to what? The ground value of this term, okay? This is the voltage. And then, what is this? No. Elastance or capacitance, because this is the what? Storage elements, right? Okay. So, this is the analog of these terms, okay? And so, we can easily solve this equation by using the what? The Kirchhoff law. If you solve it based on this information, and so this system must be solved by using this analogy. And so this system may be added the two currents in here like this one, and so maybe you have the easy solution based on this information. This is called the analogy, okay? Any question? Do you understand this topic? Okay, this is called the analogy. And so we can easily convert the anything into the another representative parts. just like the capacitance, resistors, and inductance. To what? To collect the whole the information into the one mathematical form. Okay?
I would love to ask, like, why do we need to convert, for example, the hydrogen into electric?
Yes, this is a good question, because if you have, for example, if you have a driver like this one, the voltage, and you have the AGT sensor in here like this one, and so this is drive to the watt to a motor, right? 0. Okay, but this motor is drive to the watt, the some spring and damper system, just like this one. Okay, and so if you have this information, you can create the mechanical equations, right? But if you convert these terms into the what electrical circuits, and then you can easily analyze this one, IC, and you can easily write that R, inductance, and C value. Okay, this is just the same with the what, with these elements, and so you can easily what apply the electrical theory or electrical theory into this one, because we have one domain to solve any system in here, just like in the state space, right? Or just like the transfer function domain, right? Because if we have this domination, and then we can derive the G mechanical S, and we multiply the whole the system with what the G electrical plant, right? Or we can multiply with what the G hydraulical S, and so we can easily multiply these two terms to what, for a given voltage value, to the what obtain degree value or the position value, which is called the transfer function, right? And this is derived from the what, the analogy principle. Okay, this analogy principle enable us to what, to create the transfer function or to create the state space in control theory or system dynamic. Okay.
Hocam birbirleriyle eşleştiriyoruz ya bunları. Bunların icadı sırasında bu tesadüfen mi oluşmuş bunlar, yoksa ihtiyaca binaen?
This is no. This is entirely depend on the what the universe rules. Okay.
Ama
The
yani şeyi anlıyorum, yani fizik kanunlarını anlıyorum.
yes, but the whole things, the spring, damper, or resistance, or capacitors must obey also universe rule. Okay, this based on the minimization rule. And so if you want to store the energy, and then you must use the spring. Okay, and if you want to store the electrical energy,
Kapasitör.
must use the capacitor.
Ama mesela kapasitörü biri oturup icat etmiş.
Yes, Faraday.
Buna ihtiyaç var deyip mi icat etmiş?
Yes.
Yoksa yaptığı
Yes.
çalışmalar sırasında bulup ya tesadüfler sonradan birleştirilmiş mi o zaman?
Yes, for example, if you
Sistemde birbirine çok yakın.
For example, if you want to drink a water for a city, right? Or if you want water in your home, and so how can you store the water? Yes, it's a cap, right? You want pull or transfer the water into this one, and so you can put the resistance in here, the open and close, and then you can easily what, drink this water, right? It's a requirement or your needing for your life support, and so this is a problem and this is a solution. Okay, But in mathematical domain or in dynamic domain, we may also have a dynamicity problem in here. And so we should model the storage energy with what the 1 divided by C values, or the capacitor values, or the compliance values of these tanks. Okay, this is identical with what? The electrical charge. For example, if you have a phone, and so we need also a battery, right? And so battery needs a current, or the voltage value, or the power value. And so how can I store it? Using the battery, or using some another elements to store or drive the electrons or the currents inside. Okay, this just like that. We have a problem and we have a solution, but as a mechatronic engineering, we need to model in the mathematics, which is called the system dynamics. And so in order to combine the whole these things into the one, we can use the math. But how can we do that? The analogy principle match the real world dynamics into the mathematical one. Okay? But just remember that we have always either store energy or consume energy or preserve energy. These three things are happen in real life, nothing else. Okay, in classical mechanics. Okay, otherwise the probability are also employed to describe the dynamics of the system in quantum mechanics. Okay, any question? Okay. Yes, it's an important question, because we have the parallel information, because we have the water in here, or some liquid fluid in here, like this one. If you want to store this liquid in that domain, if you have this kind of serial representation in this term, firstly, this C must be what? Field. After that, this C is broken to hold the connection in here, right? Because it's field. But in this case, if we provide the fluid in here, like this one, instantly we provide another water or the liquids to the water outside of these terms. And so this is the representation of the RC values in here. Okay, instantly we transfer liquid into the input one and the output one instantly. But in this form we cannot do that. Okay, you understand what I'm saying in here? This is not the identical representation of these terms, because if we have this kind of capacitor in here and then we can transfer the output currents instantly, while we can have the input current just like this one. But in this case we cannot do that. Okay, for example, if we have this K1 and K2 for a given M. Okay, what's the identical representation of these terms in here? This is a serial element, right? We cannot sum these two things. We have KT, which is equal to K1, K2 over minus 1, right? This is the behavior or the dynamic of these terms. And so how can we create this effect in the electrical notation. We have the voltage value in here, like this one, and so we have the inductance value in here due to the mass. But how can I build the spring in terms of the what? Electrical domain. C1, C2. Is that right or not? No, because in this case, this current instantly I1 and I2 creates these two things. But in this case, if we push this M to this one, firstly K2 is moved, and after that, due to this moving, we have K1 displacement change. Okay, and we should revise this equation with this one, right? Okay. It doesn't matter in here actually, but you are correct. C2 and C1. If the values of the K2 is different from the K1, and so we need to use that. Okay? Any question? Okay. I don't understand your question. Uh-huh. 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 Okay. I revised this equation. No, I'm sorry. You are asking about this term, right? How can we create these caps like this one, C1 and C2, in the what? In the hydraulic domain, right? Okay. And so we have the voltage value in here, and then we can draw the what? The sum tank just like this one, right? But this tank should be goes to the what? The another tank. Okay. And after that we can add the R2, R1, and so we need to add the R1 and we need to add the R2. Okay. And so this is ground, and so this must be 0, and the P should be applied in this case. Okay, this is a double tank, and so this must be also to the what? To this one. Okay, the first tank should be filled, and the another is what? Filled, or the otherwise. Okay, and so this fluid firstly goes into the what? The C1 tank, and after that C2 tank possess this water or the liquid values. Okay. Uh-huh. No, so this the R1 and the current is coming here, okay? And C1 store the energy and C2 store the fluid or mass in here, and after that we have the R2 in here because we have these currents. Just like this one. This is your example? Is your question? Okay. So R3. Where is it come from? R3. C2 is affected from this one, right? And so if the C2 is affected on this one, and then we can either R3, which is given here, or another term. This is true representation right now. Is this? Why? Okay, just remember that we have this tongue in here, okay? R1 and R2. This is a simple case for this. R1 R2, R1 and C. How can I apply this rule to this one? No. This is the rule of this term, and so I can use as an identical term into this one. Okay? How can I do that? This R3 which is given in here, or which is given here. Just see this example, and then the C2 is removed, or the mass of the C2 is removed from the what? The R3 and R2, and cannot be linked with what? The C1, right? And so this is wrong, because the our basic example shows that. Okay? You understand how can you improve or analyze the system by using the basic examples in here. Okay? Any question? Yes, but the C1 is constantly in here, fields. But if the C1 is what? The field, and then this current must be what? Broken in this case. But in this case we have the infinite height of distance in this model. Okay?
What I don't understand is technically how I imagine it is the water flow and C2 field before C1 gets filled.
Yes.
Wrong imagination?
No. If you build the system dynamic equation, maybe C2 is filled at the first place.
But if C2 is filled first, then shouldn't the first system have C2 in the beginning?
But how can you know that? You should, if you build this equation of motion, and then maybe C2 is filled.
So it's not known. I cannot make this assumption.
Yes, but if you want to drive this equation or provide the real feature in this case, and so you must limit or restrict the height of these values, and so you should also model this h in your system dynamic equation. Okay? Okay. Any question? Okay. If you don't have any question, and then in the next week we will talk about the transfer function or the frequency domain application in control system theory. Okay? That's all for this lesson. Have a good day.
Buradaki anlattığınız dersler çok kolay gözüküyor. Yani bol eşittir, bol. Gerçek hayata o kadar mı kolay?
Yes. Yes. It's simple as in the real life application, but you must split the whole system into the parts. Okay? Sub 1, sub 2 and sub 3, and so everything can easily be modeled by using these terms. But you have the 10 system at this case. Okay?